Welcome to OSG solutions for electric vehicles. This is for CVJ, that stands for constant velocity joint. CVJ is one of the parts of drivetrain. There are some types of CVJ, such as steering, half shaft, and propel shaft. And also, half shaft and propel shaft have fixed type and sliding type. Here is an explanation of both fixed type and sliding type. Fixed type has a large working angle like the image, but it doesn't have any axial slide. There is only ball type for this fixed type. On the other hand, sliding type has small working angle, but it does axial slide like the image. There are not only ball type, but also roller type for this sliding type. Here is a type of CVJ. There are mainly four types. Bar-filled joint and double offset joint are similar type, and tripod joint and shadowless free-link joint are similar type. Like these types, CVJ consists of several components. In this presentation, I talk about the application for bar-filled joint and double offset joint. So these are the parts and the machining process of each part for bar-filled joint. Bar-filled joint consists of four parts such as outer lace, cage, inner lace, and ball. And there are cutting in outer lace and inner lace and cage. These are the parts and machining process for double offset joint. It's almost the same as bar-filled joint. There are also outer lace, cage, inner lace, and ball. And there are cutting in outer lace and inner lace and cage. This is the application of outer lace and inner lace. The shape is vary depending on the model of automobile. Material is carbon steel and hardened steel. And there is a track groove in both outer lace and inner lace. As for the soft milling, it's sometimes done by forging and it's sometimes done by cutting. As for the hard milling after heat treatment, it's done by milling tool. The estimated tool size is from 40 mm to over 20 mm. This is the application challenge for soft milling. Since this part is used for all automobiles regardless of gasoline engine or electric vehicle, the production amount is very high, so low CPU is required. And many tooling suppliers provide inserted indexable end mills for this application. Then tool price itself is very low, but tool life is not very long, which means the customer has to change the insert early. Then OSG can propose special PXM type end mill for this application. PXM end mill is able to have more number of flutes comparing to insert type end mill, and this type can have more sharpness because of the spiral helix, so much longer tool life can be expected. This is the application challenge for hard milling. Since the work hardness is around 58 to 63 Rockwell, the tool life tends to be short, even with coated carbide end mill. But long tool life is required due to the high production amount. So special PXM type CBN brazed tip end mill can be proposed to this application. CBN tool achieve longer tool life than carbide end mill. Also, CBN tool can be done retip and regrind to reduce the tool cost. Next is the application of cage window. The shape is vary depending on the model of automobile. Main material is SCM and SCR. And there are soft milling before heat treatment and hard milling after heat treatment. The tool size is from 8.4 mm to 12.4 mm. This is the application challenge for soft milling. It's easy to cause chattering due to poor workpiece rigidity. Also, long tool life is required since it's high volume production. Then OSG can apply A-brand AVMS for this application. AVMS has variable helix and index geometry that are very good to suppress vibration. Also, Deorized coating has high wear mount resistance and it achieves long tool life. This is the application challenge for hard milling. It's just for finishing. It's not easy to cause chattering. But the tool life is very short because of the work hardness. But long tool life is required because of the high volume production. So OSG special CBN brazed end mill is good to achieve long tool life in high hardened steel. Also, tooling cost can be further managed by retip and regrind rather than purchasing additional new tool, and it helps to reduce the CPU. Here is an example of the actual cutting data. Work material is SCR steel. Hardness is 62 Rockwell. Cutting speed is 1150 SFM, and feed rate is 2000. The workpiece had 8 windows per part, and this special CBN tool could achieve 1500 parts. That means 12,000 windows in total.